Okay, where are we? I need to remember where I was before. Uh, oh yeah, that neural network, I think. Yeah, that neural network. Okay, where was I? Feed forward. Okay, feed forward. That's it. Okay, feed forward. Okay, we need layers. Okay, if no, that's not necessary. If prime equals 0, no, we don't need that. Layers equals same as for deletion. If layers okay, do we do the same? Yeah, network length. How does this work? Yeah, layers has you need at least 2 layers. If parent dot network length is less than 2, return 0. We need at least 2 layers, otherwise it won't work. Okay, I equals 0, I equals parent dot network length minus 1. Okay, let's not get this wrong. Parent dot network length minus 1. Switch layer to type. If layer null, okay, type null layer. Okay, I need to null layer. Oh, there it is. That what is it? Feed forward. That null layer feed forward. No, it's this one. No, it's feed forward. Layers.I and layers.I plus 1. No. Layers.I to layers.I plus 1. The feed forward part's taken care of. Okay, for each layer type, we just call the necessary feed forward operation for that particular layer type. Okay, yeah, it doesn't really take much. Return 1. Okay, if layer, then we do the for loop, and that's pretty much it. Each layer type takes care of itself. Okay, that's for feed forward. Backpropagate's a bit more complicated. Okay. Okay, I'm not going to do backpropagate outputs because we assume that everything is already set. But there's a bit of complication here. Backpropagate. Okay. Okay, backpropagate. First of all, we have to do backwards. For I equals parent.network length minus 1 to I is more than 0, more than or equals 0, I minus minus. And of course, it has to be a signed variable, so the counter has to be set to long. Okay, I made a mistake with this before. The counter needs to be set to a signed value. Int would do, but just to remember, unsigned long works here, but it doesn't work down here. Okay, so we select the last layer. No, the second to last. Oh no, it's not minus 1, it's minus 2. Okay, oh. I minus 2. Okay, so it has to be network length minus 2. So you have to, the one before the last one, the layer before the last one. So it has to be network length minus 2. I is more than or equals 0 because we're going backwards. Is more than or equals 0. It has to be more than or equal. I'm trying to think this through here. Yeah, that's it. So you have to go backwards, and then we backpropagate. Let me just copy this. No layer backpropagate. Backpropagate exactly the same thing. Layer I plus 1. We do backpropagate exactly the same way. Let's just make sure we got everything right here. Go copy from layer. No, whoa. That's very bad. Deltas, because we're copying the deltas from one layer, from one layer to the previous layer, but from the next layer to the current layer. Make sure to not get this wrong here. Okay, do I get this right? let's just clean this up right now. Okay, don't have to deal with this ever again. Okay, backpropagate. Why does it do that? Stop doing that. Okay, we have a problem here. Oh, no, 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 no. Just keeps doing that. Where do you have feed forward? Oh, God, no. Oh, come on, no way. It's just gonna keep doing that, isn't it? Oh, that's so hateful. Copy. Why is it so sensitive? Paste. Okay. Okay, so we're just gonna need other layer types. Okay, so we clean that up and we don't have to deal with this, well, for now. Okay, null layer backpropagate null, feed forward, backpropagate. I think it's done. Okay, so let's add a new function here. Get outputs. Now feed forward, set outputs, neural network get outputs. Get outputs. Type null array. Result. Okay, how do we get the outputs? We need to copy. We need layers, of course. Layers. If parent equals 0. Could a neural network null array copy? Well, copy. What do we copy? Layers. Layers dot parent dot network length -1. We have to select the correct layer and we take the outputs of that layer. And layers dot parent layer outputs. We copy the outputs into result. Wait, no, that's completely wrong. Actually, result is parent. The first variable is not result. Layers dot network length -1 dot outputs. We get the outputs, but we still have to feed forward. Feed forward just assumes that everything is set up correctly, but we still have to set up the input. Set outputs. Set data. Set outputs. Source. Set outputs is this maybe get complicated. Set outputs. Everything is the same here. I'm just trying to figure out an elegant way of doing this. Return copy again, but this time we copy into of the first layer. Layer output of first layer source. We copy the output in the first into the value of the first output. Okay, but there's something else. Backpropagate outputs. There's another function that we need for the backpropagation. This is not the right way to do this, but I'm just trying to do it elegantly. The reason I don't want to just call feed forward with the source is because we're going to have multiple kinds of feed forward. Feed forward array. We're gonna need multiple kinds of feed forward. So I want to keep this clean. So I can add it to something else. Okay, feed forward array. Example doesn't sound right. Let's call it feed forward array. Feed forward array. I'm just trying to come up with a good name for this. Feed forward array. We just feed forward an array. We can also feed forward a network, but feed forward array will do. Feed forward array, get outputs. No, feed forward copy dot source and it none. What am I doing? If. Oh, this is bad. This is bad. If layers also. We need to do if layers because there might not be a layers. We have to program defensively. That's one basic rule. Okay, let's program defensively. Okay, return 0. Okay, neural copy in the source and then call feed forward. Neural network feed forward parent. Return. Well, if this part doesn't work, we don't care. Parent. Neural network feed forward. Feed forward array. Backpropagate array. Okay. Feed forward backpropagate array is slightly different. We can't just copy here. Backpropagate array target. Change the name, but we can't just copy. We have to do subtraction. Well, no array. That's why we need subtract. Backpropagate array subtract. We have to subtract layer.outputs. I keep forgetting why I need to subtract. Okay, we need the outputs. Okay, not deltas. What am I doing? Why does he keep doing this? .network length .layer outputs. Okay, we subtract this from this. I need to remember what the right order is. We subtract the output from the target. And then we store the result in the deltas. I need to remember to do this right. Deltas. Okay. The order matters here a lot. We have to do subtraction. Is it outputs? Okay. Is it output from source or source from outputs? I have to remember how to do this correctly. I'm pretty sure it's output from source. Source, because if you get it in the wrong order, things are going to break. Parent.network length.nail deltas. We subtract the source from the outputs or the output from the source. Let me go check. Oh, now I got it. It's deltas first, then output. We subtract source, not source, target outputs. Okay, backpropagate array, targets and outputs. We subtract it, and then we backpropagate, not feed forward. Backpropagate. Neural network backpropagate, not feed forward. No, don't get this wrong. Backpropagate proper. Okay, that's it. I think we got it. Now we need to check if we miss anything. Neural network feed forward. La di da da da. Network get outputs. You just copy from into the result. And neural network backpropagate array is copying from the target, subtract from the target, and then do backpropagation. And then source feed forward array source. We just copy into the first layer, and then we do feed forward. backpropagate array, get outputs, and so far that's it. But we still need to test it to see if it works. But before we can test it, we need a way to add layers. Neural network create. Now we need to add a layer. Okay, long neural network, add layer. Add layer. Okay, type neural network. How do I add a layer? Okay, width, height, depth. Okay, unsigned long. Oh no, we just add a layer a blank layer, and then we can set it afterwards. Okay, we need a way to add a layer. Type neural layer. Okay, it has to return a neural layer type. Static. Static just means it's not supposed to be visible from outside. Okay, we need layers. Where do we find layers? Okay, gonna neural layer, layers. If parent equals 0, return 0. We have the layers. And then now what? I've done this before. Yeah, image list. Okay, add image. Okay, how do you add an image to? Do I have add image? Oh, how do I add an image? Oh, resize. Okay, we need to add a layer. If dynamic array resize. Okay, no. No. Image list. If dynamic array resize. Where's I? Image list page. No. If dynamic array resize. We don't need that one. Not yet. If dynamic array resize parent.network data. Network data size of that neural layer. Parent. Okay. Parent.network length +1. But not image list page. Where is it? Network page. Okay, network page. If it works, then we're good. Okay, what's wrong here? I equals 0. Why? A sub-expression may overflow before wider type. Yeah, that doesn't make sense. It's just being weird. Okay. Well, if we size, then we do what? I need to figure this out here. Let me pause a moment. Okay, if we size parent.network length. Parent. Wait, no. Am I right? Parent. Network length ++ increase. Okay, layers. Layers equal what? Not layers, it's the type here. Layers equals this, and return layers dot parent.network length -1. Oh, why is that here? Layers parent, no, not layers. Layers dot parent network length -1. Okay. The reason we do it -1 because what we're returning, we need to increase this, but we need to return the index. So if it's 1, then it's going to be 0. If it's 0, then we have a problem. Return 0. Okay, so it just returns it. It resizes the dynamic layer, the dynamic array, and increase the length, and then returns a layer. Okay, now long. Now we need to create a proper layer. We need to create a proper layer. Add layer. Add layer null. add me a null layer. Unsigned long, width, unsigned long, height, unsigned long, depth. Okay, I sense some problems on the horizon. This may be problematic. If neural network add layer. Well, before that we do that with parent that neural layers. I'm gonna keep it plural, but if oh no, type neural layer add layer layers equals type neural layer add layer parent. We don't actually do anything. We just add it in there. If layers. It's a single layer, but we just keep it plural. Okay, if layers return. Do you even need to check? Yeah, maybe we do. If layer type neural layer create. Type neural layer create. Actually, you don't even need to check because this one will do the checking for us. Type neural layer create layers. Layers width, height, depth. No, what am I doing? Depth. Okay, it does it. Width, height, depth. And that's it. Now let's do a little cleanup. I'm gonna pause this because it's gonna take long. Okay, I just did a little housekeeping here. Where am I? Where is this? Okay. Just move all the function names up here. Just to keep things obvious. Oh, what am I doing? Ah, why does it do that? Okay, all the function names are here. I'm gonna add a lot more functions down here later, but for now this will be enough. Neural network add layer, feed forward. But now we need to actually test this to see if it works. Okay, where are we? Emboss. Yeah, we don't need all this. I don't need all this. Image list, image 0, sequence, index map, shape 2. Well, maybe I need this. Okay, you don't need all this. Index map convolution, shape assign. I don't know if we need this. Sequence create, we need sequence. Image create, we need image 1. Shape assign, I don't think we need this. Convolution, no, we don't need that. Shuffle, maybe we need that. Image list, get image. Break, yeah, we need that. And we need this. Oh, we don't need that. And sleep, we may need that. Okay. No, we may need that. Okay. Type neural network. Okay, include neural network. I don't know if I'm gonna get this right. Type neural network. Network. Oh, now I remember. I need a way to convert. Oh, this is gonna be painful. Oh, we're not done. Oh, it turns out we're not even close to done. I need a way to convert images to arrays because it's not as simple as it sounds. Wait a minute. Okay, I just realized we're missing something important here. Oh, it's gonna take a while. No, not type def structure, long. Okay, should I put it here or here? Yeah, type null array. Okay, let's add a function to type null array. Okay, long. that neural array, set image data, set image, set data, set image data, not data, data. Okay, that's a really complicated one. Unsigned long image width. No, what am I doing? Unsigned long image height. Unsigned long image data. Unsigned long. Don't even know if I can complete this tonight because it's one of those very complicated functions. I remember doing one way back. Okay, if parent equals, yeah, we should probably do this later because it's really complicated. I don't think I can do this tonight. It's one of those really long, complicated functions. I'm gonna have to figure out a lot of the details. So let's just review what we got so far. Okay, that neural network. A neural network is just a list of layers. Same as we need a dynamic array that contains the list of layers. The layers themselves are just structures that copy from one layer to the next. All the hard mathematics stuff is done down here. Okay, and we create the network by just creating a dynamic array that's a list of layers. Here we add a layer by just resizing the array to be the size of the number of layers times the size of each layer, and then we just return oh, mistake. We have to return a pointer to the next layer. We actually have to return a pointer to the layer, not just image list has that, I think. Oh, it doesn't. Oh, yeah, that's it. Like as in here, it's a pointer to the array instance. We can't just return the the layer. That's something I would have missed. Okay, so just make sure that there are no mistakes here. Yeah, it's one of those mistakes that you can spend hours chasing down. No layer, add layer. If layer is added, then we create a layer. Different layer types we have different names. Add layer nulls, add layer matrix, add layer convolution. Each layer will be added here. Just create a copy of this function to add different layer types. To feed forward, we just copy into the output of the first layer, and then call feed forward for each subsequent layer. Backpropagate away, we just subtract. We call subtract from the outputs of the last layer from target, and then store the result in the deltas of the last layer. And then the get outputs just copy from the last layer for the outputs of the last layer into an array. And then feed forward is just loop to each layer except the last one, and copy from that layer into the next one. Backpropagate just do it backwards, starting from the second to last layer. We copy backwards from the next layer into the current layer, and then destroy. We just loop to every layer for each type of layer. We call the corresponding destroy type for that layer. Each layer is going to be different with something which does something different. Okay, we don't have time for anything else tonight, so we're gonna do the rest tomorrow.